Hi, Nicole. How are you?
I'm finding you, sir.
Oh, I'm good, thanks. Hey, which part do you need help with?
Trigonometry, sir.
Oh, all right, all right. Let me then go to my document. How's the holiday going?
Hey, sir, I'm still going to school.
Is it?
Yes, sir.
How is it there? Are you guys having fun?
Yes, sir.
Oh, that's good to hear. That's good to hear.
Yes.
Uh, Let me just share my screen now. Share and then I share again the screen. Can you see my screen that side?
Yes, sir.
Oh, okay. Then let me quickly go to the textbook. So, which part of trigonometry do you actually need help with?
The identity, sir.
Identities. Okay. So, with
Yes, sir. Like
identity
proving left hand side, right hand side.
or proving. Okay.
Yes, sir.
So, I think what you first need to know, oh, this is what is important right here on the screen. It's a summary of what you need to know the most. They are saying here when two expressions give the same results for all values of the variables for which they are both define the equality of this expression for identity. Okay, when proving identities, we always work with the two sides, the left hand side and the right hand side separately, okay? And simplify or manipulate the two sides till they are equal. And then to do this, we use trigonometric principle, then the basic identity. I think we once talked about this, that wherever maybe there is tan, you can just change that tan into sine over cos. Maybe it will help you out, or then I can add this information. Uh, I'm sorry a bit. Or you can add this information if maybe you see cot theta, then you can write that as 1 over tan theta. And then if you see sec theta, that will be equal to 1 over cos, and then cosec theta, that one is equal to 1 over sine theta. So do you see these four parts here? It's one, two, three, and the fourth one is this one.
Yes, sir.
So yes, wherever you see tan, just try to change that tan to sine over cos. That might help you. Or also when you see cot theta, try to change that from cot theta to 1 over tan theta, okay? If there's no cot, if there's sec, then change that sec to 1 over cos. Then if you see cosec, change that cosec to 1 over sine. Then you might forget to, if it's tan, do I change, if it's cot, do I change to cos or tan? So this is how you're going to look at it. I said to you, you look at the third letter of the ratio. So in this ratio, the third letter is T. So yes, you're going to change to normal trigonometric ratio that starts with T, which is the tangent. So, okay, that is called sec. When you go to sec there, the third letter in sec there is C. So which trigonometric ratio, those one that we know cos, sec, and tan, that starts with C. It's cos. That means that from sec, it's 1 over cos. Then cos sec, when you look at the third letter is S there. Then you go to the normal trigonometric ratios that we know. The one that starts with S is sine. Therefore, cos sec theta will be equal to 1 over sine theta. Does that part make sense? Hi, Nicole, are you still there? What is now happening? Oh, my mic maybe is off. I'm not sure.
Yes,
Hi,
sir.
Nicole, are you still there? Hello, Nicole.
Yes, sir.
Uh, did you follow everything that I've said here? Or you
Yes,
need
sir.
some explanation? Or you need some explanation on that?
No, sir, I
Are you
understand.
are you sure?
Yes, sir.
Okay, thank you. Then we are done with the first part of these identities. Then here we've got this part here. Okay, so that's the very important tool, this one. That's a very important tool, that one, whereby we are saying sine squared x or theta or any unknown that you can let it be, sine squared x plus cos squared x is equal to 1. So wherever you see sine squared x plus cos squared x, or these two terms have got the same unknown. If it's theta throughout. If it's x throughout. And the other one is sine, the other one is cos. Both of them are squared. They will give you 1, those two terms when you sum them up. Do you understand this part? Hmm. Are you still
Yes,
there?
sir.
Oh, okay. Now let me ask you this question. What do you think this will be equal to? Uh, do you agree to this or no? Let me do this. Why am I writing so big? Uh, Sine squared x plus, not sine, cos now. It's cos squared y is equal to 1. Do you agree or disagree to this thing that I'm written here?
I disagree, sir.
Why do you disagree?
So I think they should both either have X or they both
Oh,
have Y.
oh yes, yes. Now you understand this identity. Okay, thanks. So wherever you see this sine squared x plus cos squared x, you can just play around that identity, put 1 for that summation. Or if maybe you see 1, you also can cook and write that in reverse. If you see 1, you know that you can write that 1 as sine squared x plus cos squared x. Then maybe you can collect your like terms, depends on what you will be having on the equation at that time. But okay, you understand this part. Now we have got those two parts there. Then that one, they just played around those terms in the equation. To get sine squared theta, they just distributed the other term to the other side. So in this expression here, in this expression here, what they did, they just took this cos to the other side, then it would be 1 minus cos squared x. They will be left with only sine squared x as the subject of the formula. Same applies with the other one for cos squared x. Does it make sense to you, that one?
Yes, sir.
Oh, okay, thank you. Then now let me add this one. I just run see it here. From or sine squared x. Why am I writing this big? I'm sorry. Let's say we are having sine squared x plus cos squared x is equal to 1. You can do something. Let's say now here we are dividing by sine everywhere. Sine x squared, 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 sine squared. Okay, everywhere. Here we will be left with 1 plus. What is, now I'm asking you this. Okay, I will come back here, is equal to, what is 1 over sine? I told you these trigonometric ratios. What do you think 1 over sine x is equal to? 1 over sine x. Hi, Nicole. Are you still there?
Yes, sir.
Oh, okay. So I was asking you about those 3 trigonometric identities or ratios that I have mentioned earlier on. Got cot, you've got sec, you've got cosec. So I want you to tell me which one is equal to 1 over sine.
So is it sine squared x over sine x plus 10x over sine x?
Which one are you asking about? This one?
Yes, sir.
Or this one is cos squared x over sine squared x. So I said we will come back to that one. But for now, let's come to this one here. I want to know what is 1 over sine x is equal to.
Oh, it's cosec.
Oh, yes, cosec. Then that will be equal to cosec. Oh, we had 1 over sine squared x. So that will be cosec x squared. Yes. Now we also have got this term here. We've got cos over sine here. Now I'm asking you this question. What is cos over sine? What do you think that is equal to?
I think it's 1 over 10 theta.
1 over tan.
Yes, sir.
Oh, yes, that's correct. 1 over tan. Then 1 over tan is equal to which trigonometric ratio?
Cot theta. Cot x.
Cot, right?
Yes, sir.
Oh, yes, cot. So you are going to have this cot squared x here. So you are going to have also, you are also going to have these trigonometric ratios here. That cosec squared x is equal to 1 plus cot squared x. So now at least you've got an idea of where this formula comes from. Do you understand it?
Yes, sir.
Okay, thank you. Then you can also play around it this way, that formula. Here, when I here, knowing the fact that uh, sine squared x plus cos squared x is equal to 1. Now we divided by sine squared x everywhere. Now you can still divide by cos squared x everywhere, cos squared x. So now what is sine squared x over cos squared x? That is tan squared x, okay, plus cos squared x over cos squared x. It's 1 is equal to 1 over cos squared x. It's sec squared x. So you also understand this one now, right?
Yes, sir.
Okay, yes. Now we are done having fun around this uh, formula. Now we can proceed to this part of double angles. Okay, for the sine double angle, I don't know where this formula comes from, but just know that sine 2x is equal to 2 sine theta times cos theta. This one here. Do you understand this one, right?
Yes, sir.
Oh, yes. So we also have this one for cos here. So the main one is this one, whereby they are having cos 2 theta is equal to cos squared theta minus sine squared theta. So if you understand that part, then now you can play around these ratios, because we know that sine squared, this part here, sine squared theta, this one here, sine squared theta is equal to 1 minus cos squared theta, which is this one. Then when you substitute it there, it will give you this. Same applies with the last one. You substitute cos squared theta with 1 minus sine squared theta. You will end up having this one. Do you understand that part?
Yes, sir.
Oh, okay. Then we also have compound angles. Compound angles. The way I memorized this one, I was like, okay, for sine, I can just say it's sine cos cosine. Then I put the angles AB, AB. Then if I had plus here, then I will also have plus there. Okay, again for sine AB, I will say sine cos cosine. And I put my angles AB, AB. And then there was minus, it will be minus. Then for cos, for cos, what's happening? For cos, I will have cos, sine, and then I distribute my angles AB, AB. But with the sign, I do the opposite. If it was positive, I'll put negative. Cos, it will be cos, sine. Then I distribute my angles AB, AB. The sign was negative, I put the opposite. Only if it's the compound, of course, the sign, you will put the negative. But if it's for sign, you put the sign as it was. Do you understand this one?
Yes, sir.
Okay, fine. Now, if you understand those identities, double angles and compound angles, now let's go to this algebraic principle, basic algebra. Adding, subtracting like terms. Oh, that's what we will mostly do in our expressions or equations when we are proving those left-hand side and right-hand side. Okay, algebraic multiplication, that's what we'll mostly do. Basic simplification of fraction, okay, we will do using the LCD to add wherever there are fractions, we will do. Then factorization, common factor, I think I told you this before. Difference of two squares, if it exists, you can go for it and factorize. Also quadratic trinomial, you can go for it and factorize if possible. Then there is this hint, Start by replacing tan by sin theta over cos theta, or we've said this. And wherever you see sine 2 theta, you can replace that by 2 sine theta cos theta wherever. Okay. Okay. Then we have got an example, I think here. Okay. Example 20, identity involving double angles. They say prove that left-hand side is equal to right-hand side. So what they did here, they changed that tan into sine over cos, and then they simplified the left-hand side, and then it gave them this. This is what they got. And then, okay, one might be shocked when getting this, and then they will be like, oh, this, why is this not equal to that? Okay, if you have solved your left-hand side until it is simplified, and then you can also simplify right-hand side, you are allowed to do so. You can simplify it just like they did here until it gives you something that is same as the one that you got on the left-hand side. Then now you've proved that the left-hand side is equal to the right-hand side. Does it make sense? And does it make sense to you, Nicole? Hi, Nicole. Are you still there?
Yes, sir. Can you please repeat?
Sorry? Hello?
Can you please repeat, sir?
Oh, okay. Can you now hear me? Can you
Sir?
now hear me? Can you now hear me?
Yes, sir.
Oh, okay, okay, then let me repeat this example 20 that I was explaining here. So I was
Yes, sir.
looking at this. Oh, okay. I was looking at this example here. At this example, we are required to prove that tan theta plus cos theta all over sine theta, that is equal to 2 all over sine 2 theta. Okay, so the way they solved it, okay, they went for that part here. This part here, they changed that tan theta to what? To sine over cos theta here. That's what they did. Okay, now they've got that fraction. They solved now that fraction into this part here. This part here, this one part here. Okay, now the numerator in that fraction is an identity. We know that sine squared theta plus cos squared theta. That gives us 1. Okay, we wrote that now as that 1. Okay, all over denominator, we keep it as like that. Okay, so now I said 1 can be shocked when getting to this point and being like, oh, okay, why now am I getting to different things? Because I simplified my left-hand side. So, okay, if now you have simplified your left-hand side, you are done with it, you are also allowed to go and simplify the right-hand side. Okay, this is how they simplified the right-hand side. This is an identity that you can split. Sine 2 theta is equal to 2 sine theta times cos theta. Then they wrote it that way, okay? Now when they are here, these two will cancel out with that 2 on the numerator. We will now be left with 1 over cos theta times sine theta. Now they have proved that left-hand side is equal to right-hand side. Do you now understand it?
So at the left-hand side, what did they do to get the numerator as sin squared theta plus cos squared theta?
Oh, okay. Let me just make this example. Let's say we have A over B plus C over B. Okay. If we simplify this fraction, we are just going to say A plus C over B. You take just B, one of them here, because both terms or both fractions have got same denominator. So you will take one of them and then add the numerators. Okay. Now let's say we have different denominators. Say this one here is B, this one here is D. Okay. Our denominator now, if it was the same denominators, we are going to take just one and put there. So now they are different denominators. In the denominator of the following step, you times those denominators B times D. Okay. For the first part here, for the part that you will put here, you will take this term A times that one D. Then you will have A D plus. For the second part that you will put there, now you will take that, you will take that C there times B. Then you put it there, C times B. Then now you will have your answer as AD plus C B over B D. Then you are done. Does this part make sense to you?
Yes, sir. Thank you.
Okay. So now are you following on how they got that sine squared theta plus cos squared theta all over cos theta times sine theta?
Yes, sir.
Are you sure?
Yes, sir.
Oh, okay. Thank you. So now here they are just doing what we've just read with those techniques our lesson. What I will do, I'm going, and then you will try them, and then those one that I will tick, you will you will just send me answers when you are done before tonight, before 7:30, and then we can together go through them and then do some corrections with you there on WhatsApp. Is that okay with you? Mm. Are you still there, Nicole? Hello?
Yes, sir.
Oh, okay, cool then. I will definitely send them now and then you can tackle them.
Yes, sir.
Yeah, then I'll see you then.